Hi, welcome to integration by parts. This is a really powerful integration technique. It's a little weird, takes a little getting used to, but you can take some things that look like impossible integrals and make them a lot easier. So our goal here is to look at our original function. So let's say we're analyzing this guy. You want to choose part of your function to be your u. So it's something you will find the derivative of, and then something where you already have the derivative. So your dv. People do f and g if that works better for you, whatever you want to do. Your goal is to get rid of one of these functions if possible. So this really, more than anything, takes practice, and you'll start to see some patterns of, hey, this sort of thing, this is usually your u, the other thing's your v, your dv rather. So practice finding them. I know the book goes through and gives you some good hints on which ones to do, but for example, if I have the one example we have below here, so I need to assign something to be my u and something to be my dv. Well, if I take the derivative of x, it's going to give me 1, which goes away. Spectacular. If I were to take the derivative of e to the x, I get the same thing back. So reducing e to the x actually isn't possible. Typically, when you have an e to the x, that's going to be your dv. So I'm going to say my u is x, my dv is e to the x. You can throw on a dx or not. I usually don't. Okay. So assign your variables. Now, and I always list them like this. So going across, find du. So what is the derivative of x? Well, it's nice. It's just 1. Now, what is the antiderivative of e to the x? Well, that's just e to the x, and we leave off the plus c for these. Cool. Rewrite. So our function says, or our formula rather, says we take u, so my u here, times v minus integral of v, so the thing we found, times du, which is just 1 dx. So I've taken something that was hard to figure out how to deal with and turned it into something much easier. We know how to take the integral of e to the x. It's just e to the x. We already did that. So our first part doesn't change. But your antiderivative e to the x is just e to the x. And now we say plus c. So again, a lot of the times when you have an e to the x in there, that's going to be your dv, because finding the antiderivative of that's not so bad. And if you have something where like an x or x to a power, that's often going to be your u. It may take some practice. You may get them backwards. You'll know if your new function looks significantly worse than your old one, you probably chose wrong. But don't be afraid to kind of make mistakes on these. It's going to happen. It helps you figure out things. All right. I always have to write the formula to this down because I forget sometimes. It is a weird little formula. So actually, let me scribble that over here. I have a sticky note, but hey, I got it right. All right. I look at this and say, okay, I want to take the derivative of something to make it go away, to make it better. In this case, if I take the derivative of natural log, that's 1 over x. That's pretty easy to deal with. So let's see where that leads us. Okay, so then my dv has to be x squared. Let's take the derivative, scoot this up a little bit. The derivative of natural log is 1 over x. The antiderivative of x squared is 1/3 x to the 3rd. Cool. Rewrite. So this says take my u times my v. I'm going to reorder that a little bit. I should probably put absolute values, but what ifs. Okay, now take my v times my du. That, once we clean it up, is much nicer to deal with. And the stuff at the beginning, we're done with it. We don't even care. It can look disgusting. All right, x to the third over x will give me x squared dx. That's a nice one to deal with. Okay. Take the antiderivative, I get 1/3 x to the third. And I already had that 1/3 on the outside, so I just kind of wrote it down there. And one last cleanup stage. Could have skipped this, but it's sometimes nice to show it. Oops. So if you use a integral table or technology of some sort of calculator, a Desmos sort of thing, you might actually get a different, excuse me, integration. But as long as they both derive to the same place, that's what matters. Excuse me. All right. This one on the surface, I would look at that and say, oh, no, that's easy. It's 1 over x. No, we're taking the integral. So, oh, how do I want to do this one? Let me write down my formula again. U dv equals uv minus v du. Okay, we're going to use 1 in one of these. So the question is, where am I going to use it? Not there. That doesn't make sense there. So sometimes if you have something nasty and you know you can't integrate that easily, you want to take a derivative of it somehow, and you just have the one term, well, you can use 1 because there's an understood 1 that you're multiplying there. So this is a nice little trick too. All right, the derivative of natural log, the antiderivative of 1 is just plain x. Okay. Yeah, if I had assigned natural log to the dv, it doesn't help me at all. It was exactly in the same spot. All right, u times v minus integral v times du. X over x is just 1. Antiderivative of 1 is just x. So that looks like a little bit of magic, and I still think so, even after all these years. So don't forget you can assign a 1. There's nothing saying you can't. You're not really introducing a new variable. You're introducing a constant. You're allowed to do that. So get our final answer. Okay, the last example, say we use integration by parts and our new integral is still really nasty. Well, do it again. And you can keep going until you can get to something that's easy to work with. If we do trig, you can get to one where you just kind of go in circles, and then there's a trick for that too, but luckily we don't have to deal with that. So let me again write my formula. Whoops. V du. I sometimes forget my formulas, so I find if I write them at the top of my page every time, that helps. This is the equivalent of doing that. All right, so I assign a u and a dv. Let's scoot these over a little bit. And then I'm going to find a du and a v. And you already know we're going to do this more than once. So again, we have an e to the x. That is probably going to be our dv. In this case, it is. That means our u has to be x squared, which makes my du 2x. Okay, u times v, x squared times e to the x minus integral v times du. So 2x e to the x dx. Let's rewrite that once more. Okay. Go down. So we still can't integrate this easily. That means we're going to do it again. I'm going to use a separate pen color to show that I'm doing this whole thing again. It may help you if you want to use F and G, so use different letters. Actually, I can do that too. So, no, actually, I'm not. I don't want to change things. U, dv, and that'll be my du and v. I used to use F prime and G prime a lot, but we won't do that. Okay, when we do this a second time, this first part is done. We need it, but we don't have to integrate it because we already did. That's already outside. It's just going to come along for the ride. So I'm going to erase that, but we can ignore it. So really, I just focus on the inside. Be very careful with your parentheses. If you're not, it's going to blow up just because of algebra. All right, we're going to assign variables, honestly, just about the same way we did above. So my u is my x, and my dv, e to the x. Do your thing. We get 1, e to the x. Cool. There's my formula. Okay. So equals, this comes down. Doesn't come down, you forget about it. Times 2. All right. U times v minus integral du times v, which is just e to the x dx. Okay. X squared e to the x minus 2x e to the x. Antiderivative of e to the x is e to the x, but we have this 2 here. So 2 times -1 gives me a positive 2 e to the x, and then we just have a plus c. We could clean that up one more stage by factoring out e to the x, but it actually, let's do it. Doesn't help us a lot. Oh, we could factor it once more if we really wanted to. We're not going to. So that's our final answer. We finally get rid of all of our integrals and it looks nicer. This is a tricky section. It takes practice seeing it. Once you know what your u and v are, it's pretty straightforward, but it takes a while to start to recognize that. So be kind to yourself on this section. It is not always the most fun, but on the bright side, we're almost done. We only have a few sections left. All right, we'll see you next section.